At 9:57 p.m. local time on June 5, 2026, the largest earthquake to strike close to the Mayon Volcano since 1938 occurred. Registering in as a magnitude 5.3, this quake centered 26 kilometers east-southeast of Mayon's summit caused the ground to shake for several seconds, also causing several local power outages. This quake caused multiple viewers to reach out to me asking if this earthquake was volcanic in origin and if it would affect the Mayon volcano. Mayon, for reference, is actively erupting and has been erupting in an effusive to explosive manner since mid-December 2025. Although its ongoing eruption is about to hit its 6-month mark, eruptive activity has, in my opinion, been slowly decreasing since February. Friday's earthquake, in my opinion, did not seemingly affect any of its geophysical data readings since they were fairly similar before and after the earthquake, and there's a simple reason for this. The earthquake which struck was not volcanic, but completely tectonic in origin. And this tectonic earthquake did not seemingly affect the underlying magma chamber beneath the Mayon volcano, despite potentially surpassing the minimum threshold of intensity needed to have a possible chance of affecting a volcano. However, the vast majority of the time, such earthquakes do not cause volcanoes to erupt anew, or for erupting volcanoes to change their activity. After all, an even larger magnitude 6.1 quake struck at a closer distance to Mayon in 1938, and that didn't trigger an eruption. But why did the June 5, 2026 quake strike? To the north and south of the Mayon volcano, there are a pair of large eastward trending strike slip faults which accommodate some of the uneven motion the local tectonic plates produce. To the north is the right lateral fault of the Lake Gaspé lineament, while to the south is the left lateral San Vicente-Lanel fault. Neither of these fault lines produced Friday's earthquake, as instead the 5.3 earthquake originated in between the two. I immediately grew suspicious when one implied solution for the direction of slip almost perfectly paralleled a branching fault of the southern fault known as the Donsol fault. I thus suspect that uneven motion of the two strike slip fault lines caused strain to build up over time until a buried branching fault slipped to accommodate some of this motion on June 5th. A viewer of mine was wondering in an email if a magnitude 4.1 earthquake that struck about 2.5 hours before the 5.3 quake could be classified as a foreshock. My answer to this is yes, it was one, marking it as one of the estimated 5% of earthquakes that denote a foreshock. While I have been loose in my interpretation of what qualifies as an aftershock or foreshock in the past, there actually is a more strict definition for the former of these terms. Specifically, an aftershock occurs within 2 fault rupture lengths of the main shock before seismic activity returns to normal levels. While this definition doesn't apply to foreshocks as well, the earlier 4.1 quake did occur within a 2-fault rupture length of the 5.3 quake. So, although Mayon did produce a rockfall during the magnitude 5.3 quake, this isn't all that unexpected considering that since its eruption began, nearly 47,000 such rockfall events have occurred. Stay tuned for more updates. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube for supporting my work.